All right, ladies and gentlemen, hello and welcome back to Inside Analysis. Yours truly, Eric Kavanaugh, here today, and the only coast-to-coast radio show all about the information economy. And I'm very pleased to have the Chief Strategy Officer of one of the original big data companies, Cloudera. We've got Abhas Ricky on the line today, CSO, Chief Strategy Officer for Cloudera. And Cloudera has a new report out, The State of Enterprise AI and Modern Data Architectures. Of course, our core audience loves to talk about architecture, and just about everyone wants to talk about AI these days. Obviously, the large language models had a lot to do with that, but LLMs are just one kind of AI. There are many kinds of AI, and AI has been in production for many years. So Cloudera knows a thing or two about that. Of course, like I said, they started off as the big data company back in the days when we talked about Hadoop, but they got a lot more than Hadoop going on these days. Hadoop is pretty much under the covers now. Many companies are moving away from that architecture. We could talk about that maybe later in the show. But Cloudera has always really been known for their bulletproof code. That's what I say to my friends over there, is that Cloudera, back in the days of Cloudera versus Hortonworks, Cloudera had the better code, arguably. Of course, those companies merged and now are one, but they're doing some interesting things. So with that, Abbas, Ricky, welcome to Inside Analysis. Tell us a bit about what you're seeing in terms of AI adoption. I know there is a lot of hype around large language models, but like I suggested, there are other forms of, let's call it traditional AI. What are you working on these days, and where do you see the market headed?
Absolutely. First of all, Eric, thank you for having me. It's a pleasure to join you guys. And good morning to our audiences in the West Coast. Good afternoon, actually, to our audiences in the East Coast, depending on where you are on the East Coast, on the coast-to-coast radio thing that you just mentioned. In terms of where we're at as a company, Cloudera, there are three core things on the enterprise AI ecosystem that we are particularly focused on. The first one is enabling customers get the highest fidelity outputs through whichever models they have: large language models, foundation models, small language models, large action models. And the way we're doing that is through enterprise context. One of the things that people might not be aware of is the fact that Cloudera has 25 exabytes of data under management. And that's more than any company on planet Earth. To give you perspective of how large that is, that's 100 times one of the largest competitor, who are a public company and a very large enterprise as well. So 2 years back, 3 years back, as you said, when the market was still starting to form around AI, a lot of people treated that data, treated that asset as storage commodity. Now, everyone wants to run large language models with their domain-specific information, with their enterprise context for the specificity that they might have. If you're a large telco, if you're a large bank, if you're a large manufacturer, automotive, like whoever, and that all of that sits on us. So we're trying to make that available through our lakehouse, the place where you've been doing analytics through tooling. And the way we're going about that is we're trying to build partnerships with the leading providers. So for example, we announced a partnership last year with Amazon Bedrock. Matt Wood of Amazon and myself, we wrote a blog about that. And the idea being you can leverage any models from usual providers like Cohere or Anthropic using Amazon Bedrock on our platform, which is Cloudera Machine Learning, using a single click. We have capabilities today whereby you can leverage models from the open source versions from Hugging Face, and you can take that and deploy using a single click on Cloudera Machine Learning. So we already have pre-built ready flow connectors on Cloudera Data Warehousing that you can leverage to take the open models from the Hugging Face repository and deploy in Cloudera Machine Learning. But we're also having partnerships with some of the other new age providers like Mistral, who have this famous Mistral 7B large instruct model as well. So the first one is making sure customers can deliver their models with the highest fidelity outputs. And we have the enterprise context. We're trying to enable that through various partnerships. The second one is,
Go ahead.
Go ahead, please.
No, it's just real quick. Something jumped out at me. Large action models. Is that what you said?
Yeah, there are different types of things. It's funny because I was at Davos early this year, and there was already talk about large action models, but also small language models as well, because LLM obviously has a lot of the mind share between practitioners and everyone alike. But where the market is headed towards, where the industry is headed towards, is having different flavors of different models for different use cases.
Hmm.
There is no one size fits all. Like take ChatGPT, for example. So obviously ChatGPT, not just 3.5, but also 4.0 is one of the most popular models out there for a specific use case. But for various different enterprise use cases, there are different models there might be. And there were different flavors that people came out with, whether that be Llama 2 or Cohere came out with Commander Plus, etc. But a lot of these have different requirements, and a lot of these have different use cases than people envisaged.
Hmm.
And one of the core requirements that came out was cost, because training models can be super expensive. So, which is a good segue into my second point, which Cloudera does, is we help customers deliver a lot of these insights and train models at a price point of their choice. And the way we do that is we have done some hardware acceleration work with some of the leading providers, such as NVIDIA. So we started with Triton Library integration with them. We have an inferencing service which has just gone live. The idea being you can take NVIDIA's NeMo retrievers and the NIM CUDA-X microservices capabilities, and you can train the models. So think of it as running scale AI workloads on GPUs, NVIDIA GPUs on private cloud, Cloudera private cloud. So the TCO is 30 to 50% cheaper than anything out there. One of the customers told us that it cost them $4 million a month less just in compute costs by doing so. So hopefully we'll see more and more customers starting to adopt that pathway. And I think that is where the full and true power of hybrid AI comes into the picture. Hybrid AI is more than making sure you can leverage your enterprise context and sources from both on-premises and public cloud, but it's actually about being able to run at a price point in a form factor wherever you feel it's most convenient and with the best TCO. And
And
lastly,
oh, go ahead.
no, just to finish up on that, and lastly, on the third point that I wanted to call out was we wanted to make sure that we are able to do all of these with an ability to do enterprise search. So the third pillar for Cloudera's enterprise AI is semantic querying and enterprise search. And you might have seen our partnership with Pinecone and public cloud, but candidly in private cloud, which is where a lot of the world's data still sits as far as enterprise AI is concerned, there isn't anything that's scaled to the level that large enterprises would like. So we're investing internally on platform areas as well, and hopefully we can get enterprise requirements on the enterprise search area as well, to the point whereby they can run it and fulfill all of the use cases they might have. So
Yeah.
those are the three pillars.
That's very interesting. And one of my good friends in the industry, we were talking just about a week or two ago about what's happening in this space. And she used a term called hybrid search. And I really like this because what she's basically saying is, look, SQL is still going to matter, even in this new natural language processing world of large language models, which I think are really going to dominate the front end of what we call decision support or business intelligence. I think that the large language models are going to invert that entire world. It's already happening. And you're seeing many organizations try to figure that out. And what they're doing is using a RAG model, basically a retrieval augmented generation, as almost as like the flywheel between the power from one side to the use on the other, basically. But what's happening, of course, is that large language models are probabilistic by nature, which means they'll never be deterministic. They'll never be 100%. And that is a problem for enterprise use cases. You want sometimes to have a 100% accurate answer. So that's where hybrid search comes into play. So you'll be using the text generative ability of the large language model, but you've also got a where clause in there somewhere for SQL to populate the hard data that you must have in those answers. What do you think about that concept of hybrid search? And does that match what you're referring to as enterprise search or semantic search?
Yeah, it's a great point, and I think you mentioned RAG applications, and I fully agree. If you look at large enterprises or even medium scale enterprises, majority of them are building RAG applications today. Where I
Hmm.
believe the world is headed towards, in 12 to 18 months' time, a lot of them will be doing fine tuning.
Hmm.
And that's where the next frontier of AI applications will be at. Now, the journey from here to there will require a set of different capabilities. One of them is enterprise search as well. And I do really like the fact that more and more people are talking about hybrid search. We were one of the few companies who started talking about hybrid like 4 to 5 years ago. And the definition for hybrid has evolved. So when the world was all about digital applications and cloud applications, a large part of the ability was the fact that you can move your workloads between public cloud and private cloud bidirectionally without application refactoring. And that's an important point because application refactoring means $3 to $7 million per app is one of the
Right.
banks told us.
Right.
And they have 67 apps to do the math. It's a significant number. When you come to AI, it's more than that because of the fact, as you said, that the outputs are naturally experimentative at an earlier stage. And because of the probabilistic and non-deterministic nature that they have, you need to get to a point whereby a lot of people are investing time in prompt engineering because the better the quality of the prompt, the better the quality of the output is the hypothesis that they're going through with it. So naturally, they want to get to a point whereby they can search all of their assets in the metadata that they have across different sources to be able to get the output that they have. So I agree, it's a super important capability in terms of having hybrid search across all your data sources because you might want to do ephemeral analytics for use cases that are analytical in nature in the cloud, but at the same time, you might want to do long-running back-end office operation analytics on premises because it's cheaper for you, but also for security and governance reasons. And therefore, you want to have the capability which spans across different form factors as well. And one small point on the point that SQL, I do think SQL matters. I do think a large part of AI is still a data engineering problem. You still have to do the data wrangling. You still have to do the data prep. You still have to make sure that they're being primed to get to the next stage beyond prescriptive analytics.
Mm-hmm.
And therefore, SQL as a language is still super important. In terms of databases, like if you've seen Postgres, specifically serverless Postgres winning the war on that front. So yeah, the traditional tools and the traditional capabilities for application developers and practitioners are alike, and they will still be very important going forward in the age of AI.
Yeah, that's interesting. And, I love this concept of large action models. And I think you're spot on to mention small language models. I think the market is still trying to scratch its head about Sam Altman saying the era of large language models is over, which was like 6 months ago or something. And we're like, what did that guy say? I think he may have seen and realized that small language models and the Mistral approach, for example, that you talked about, do have significant advantage. And what I'm seeing is a real focus on ontologies, on domain specific small language models that are designed to represent a particular vertical, like life insurance, for example, or manufacturing, because in those worlds, you can narrow down the focus. And that's another term we've heard a lot about too, right? Narrow AI. That has been the most successful AI, historically speaking, is narrow AI, whereas large language models are very broad, but they're really just text generative or image generative in nature. But I will suggest that I think that the vector database similarity search is going to become very prominent in our world going forward. But we're throwing a lot of stuff at you here, but you're the chief strategy officer, so I want to get your take on some of these things. And one word I haven't heard you mention yet is agents, AI agents. What's your thought on AI agents, and where does that fit into Cloudera's vision?
Yeah, that's a great point. So you mentioned 2 points that I want to come back on. One of the things that I just heard you talked about similarity search. So let me quickly address that. So
Yeah.
Cloudera has something called as applied machine learning projects. So if you Google Cloudera applied machine learning projects, there's a library of AMPs that comes up. AMPs is nothing but think of them as a way to get started on specific use cases. So we just launched a new AMP with Cohere and Facebook AI similarity search model. So think of that as a streamlined application that you can use, and it leverages Facebook AI similarity search and Cohere's Command R plus model as well, but also their embedded models to do PDF documentation analysis. It's a simple use case,
I
but
saw
you can
that.
get
Yeah.
through with it. Yeah.
Yeah.
And similarly, we have one with Mistral as well. So I do think similarity search is picking traction in large enterprises as well, which brings me to my next point, which you said, which is agents. So I do think the future is agentic applications. Some large enterprises have taken lead. So I was recently in Singapore and I was sharing stage with one of our largest customers out there in the APAC region, OCBC Bank. And they mentioned how they're using vision language models. So effectively think of them, if the idea is to file or do due diligences on a mortgage applications, people have filed in their tax returns, their W-9s, etc. The ability to look at their images and get to an insight which is of higher fidelity than a normal text summarization would do, or a normal copilot that will get through that, that's what they're doing. And one of the ways they're doing that is through agents. In fact, they said that they're using technology today to the point whereby almost 77% of their LLM calls are being done by agents today. So that's just today in production. And they're doing all of that using Cloudera machine learning. So the role where we play, we come in is we expose the data to these agents. Just like back in the day, in plain simple language, we were helping expose the relevant data to the APIs. Now we're helping expose that data to these agents so that they can make the relevant calls. And the second point that you mentioned, I think, is spot on. You've hit the nail on the head, whereby I do believe a lot of the verticalization efforts will take place through agents. So obviously there's value in horizontal orchestration capabilities that some of these agents are, or agentic companies are trying to build through. And naturally, people and practitioners will build on top of that. But over a period of time, whether it's manufacturing or financial services, or whether it's pharmaceuticals, because we have a very large customer who are running all of the canonical drug discovery research on us today with generative AI use cases in production.
Wow.
The aim being you want to reduce the time for drug discovery. Similarly, we have a very large luxury car manufacturer, not hard to guess, from continental Europe, who are running all of their future electric vehicle programs, supply chain, after sales on us as well. One is a horizontal use case. The other one is a very specific vertical use case. Both of them will eventually start using agents, but I think the vertical one will have more focus on agentic applications than the horizontal one. So I completely agree. That's where the agentic ecosystem is headed towards.
This is very, very interesting stuff. Folks, don't touch that. We'll be right back talking to Abhas Ricky, Chief Strategy Officer of Cloudera. They're on the front lines, folks, forging forward. Very interesting stuff. We'll be right back. You're listening to Inside Analysis. All right, folks, welcome back to Inside Analysis. Your host here, Eric Kavanaugh, with Abhas Ricky, Chief Strategy Officer of Cloudera. In that first segment, we tackled quite a few topics, and I can tell that he is able to go in just about any direction. And Abbas, you mentioned one thing in particular that really jumped out at me, and I'm calling it the other shoe that is yet to drop in the AI game, and that is cost. I mean, we've seen, so I come from the data warehousing world. So 24 years ago, dove into this industry. ETL was the name of the game. You built a data warehouse on Teradata, and that allowed you to kind of analyze your data. That's my background and where I entered this industry. And so I'm very cognizant of how long it takes to build solutions and then leverage solutions and then get business value from them. And obviously, the patience on that front is a lot slower and smaller than it used to be. You can't just have some 2-year project to build a solution and hope there's value at the end. No, you can't do that anymore. You got to move quickly. And we can move quickly thanks to the cloud, thanks to AI, thanks to sophisticated methodologies by companies like Cloudera and others. We can do that kind of stuff. But I still think this cost shoe has yet to drop. And so let's just kind of walk through a little bit how architecture and built-in agility can help this, and observability too. There's some really cool stuff happening in the fintech space and just being able to monitor activity and know where cloud costs are going. Because the old joke a few years ago was that the most ungoverned line on your IT budget was the Amazon bill. And I think that's starting to change because we have so much visibility, because we have good fintech, because we can see what's happening. But to get the right architecture, you need visibility into every one of those pipelines, right? The data pipeline, the inference pipeline, all that stuff. You need to have visibility into that and what impact it's having on your business. How does Cloudera enable that?
Yeah, it's a great point. Look, Eric, the cost thing is not net new. If you look at Cloudera's history, you mentioned Hortonworks as well. So I joined Hortonworks back in the day, and this is my ninth year with the company.
Wow.
So it's been a great run in terms of helping our customers, partners, and employees get to various iterations that we might have had. But the two commonalities that we've had as a company in terms of value proposition, one is total cost of ownership. That's one of the core things that we've always tried to optimize. And we can say with a lot of certainty, even today, that is one of the core reasons why customers select us. And then the second one is, as a strategic partner of choice for the world's largest enterprises, metadata governance is the core piece that we're focused on. And that still holds true, whether it's the AI or anything else. Now, if you look at the cost paradigm in the cloud versus hybrid argument, there were certain parameters whereby architecturally you could look at your lakehouse architecture. So we were one of the first who powered our lakehouse with Iceberg, the open source community as well. And the reason was because as an open source community, that's where the practitioners wanted to get through with it. And there are instances whereby we have a customer who are able to reduce, for example, their Snowflake bill by up to 50 to 75% just because of the fact that they're leveraging Iceberg. You mentioned Spark. Spark is still the engine for us today. Like $500 million of Spark ETL is what we have running today. So for a lot of the enterprises and practitioners, as much as there's AI, as much as there are new age use cases that are going after, Spark ETL is still the rules to roost for a large part of the new and expansion dollars for us as well. So getting customers to a point whereby they can have not just a better TCO, but also the ability to look into the cost, what it looks like, is one of the core things we've got into. So Cloudera Observability is a product that we have, which allows you, to get you a better sense of your pipeline and workload observability, but also helps you with some of those FinOps capabilities, because a lot of times CIOs will come to me and say, hey, Abhas, I want to have the ability to charge back to lines of businesses. And therefore, we wanted to get to that as well. Now, observability is three forms. There's infrastructure observability. You have the Datadog world. You have pipeline observability, and you have workload observability. Cloudera's customers largely asked us to focus on the workload observability first. And that's the piece that we're focused on. Now, if you fast forward to the age of AI, I'm sure you read the article from Sequoia, the $600 billion problem. I personally am a little bit of a more of an eternal optimist. So I do think, yes, it will be in the early days, costs will be a little bit prohibitive to certain large enterprises, but also medium-scale enterprises as well, because training models isn't easy. And that's where I talked about hardware acceleration. Getting a better sense in terms of observability is even more important in the AI world than anything else. So for example, we were just speaking to an Australian bank at our event in Singapore, and they said, whether it's the use case is text summarization or chat Q&A or Copilot, for each one of them, if they can have a better sense that what is the overall workload cost outlay by practitioner groups, that's even better. But to be able to get there, they need to incorporate a certain set of architectural today. So what Cloudera does is Cloudera does two things. We make sure that you are able to leverage the modern data architectures, namely the data fabric that we have with the metadata governance and replication and observability. So our fabric, we don't monetize largely, but our lakehouse is what we largely monetize. Think of the lakehouse as engines too. So ingestion, data engineering, data warehousing, machine learning, visualization across public and private cloud. But the second thing is we're starting to work on capabilities such as query federation, making sure that people can truly realize the data mesh architectures, making sure you as a practitioner can use data as a product. And that's where we want to get towards. So that combined with our latest observability products, we do believe customers will have a better sense about the total cost of ownership, not just for their actual architecture for digital applications, but also the ones that they will leverage for their future AI applications as well. So if I'll try paint you an image of our stack. So think of that as a fabric that you have at the bottom. Below that, you have the hardware acceleration. That's one level of cost optimization with the NVIDIAs of the world, with the AWS inferences of the world, and everyone else, etc. So the hardware acceleration, fabric, lakehouse on top, which is the engines, And then on top of that, you have the data mesh on one side and the applications AI suite on the other. I wish I could show you a slide, but next time, that's what we'll go towards as well.
Yeah, no, that's very interesting. And since I know a lot about Cloudera and its history, originally Cloudera was an on-prem company, and you've gone full force into the cloud now with partners and doing a lot of interesting stuff there. I still believe that the rumors of on-prem's demise have been greatly exaggerated. I think on-prem is going to stick around for a while. What do you think about that? Are there use cases that make more sense to keep on-prem, for example, with intellectual property or personally identifiable information? And are these hybrid cloud architectures getting to a point where it doesn't really matter where your data is? Because there are some very interesting companies out there. There's a company called Hammerspace you may have heard about, which is creating this unified namespace for all of your data, which turns the whole data movement storyline sideways. So my question to you is there a future for on-prem in Cloudera's vision? And if so, what does that future look like in your opinion?
Absolutely. So we're over $1 billion in revenue and growing really fast. If you look at our cloud business, naturally, that's the fastest growth engine for us. That's growing multiple times faster than the on-premises business, albeit it's a different baseline denominator-wise.
Hmm.
Having said that, if you look at the largest bank, the largest telcos, the largest insurers, majority of the industries that are in the regulated spaces, they oftentimes have to deliver certain use cases which are running all the time, 24/7, 365. Cybersecurity, you mentioned that. Even if you look in a bank, whether it's an AML or a KYC use cases, a large part of the front-end applications might be built onto public cloud, but the data sources might be on premises. So
Hmm.
the definition of what you and I thought of as traditional on premises has evolved. What you and I thought as hybrid has evolved. There is a very large oil and gas company who came to us and told me that, hey, Russ, we're doing hybrids. Like, what's your hybrid use case? They're like, well, we're using NiFi, which is Cloudera's ingestion engine, to stream data from on-premise sources into Cloudera public cloud. And in sometimes they're also using in some of our competitors as well, depending upon the use case there might be. That's hybrid for them. So they're not doing any analytics on premises, but they're pulling the data from on-premise sources onto public cloud when need be and putting it back onto production once the analytical suite has been done in the cloud in on-premises for only two reasons: cost and metadata governance. And the famous blog from Martin Casado from Andreessen, whereby he said emerging architectures and people who are on private cloud won't be able to go to public cloud completely because of cost and security reasons. People who are on public cloud won't be able to stay on public cloud completely because of cost and security reasons. And I do think that that's true even today, because whether you look at the architectural concepts, whether you look at how people are implementing the facets, but more importantly, where the data sits, majority of the large amount of data is still going through. I'll quote the CIO from one of the very large bulge bracket banks, and she told me about our goal is to be able to get in the age of AI, our goal is to be able to get to a point whereby we can bring the models to the data and not the data to the models, because
Wow.
that is super expensive. So yes, I do believe that there is a place for on-premises. There's a place for therefore hybrid architectures as well. But the way Cloud is going about that is we have containerized data services. We have private cloud data services with the sole goal that you can have the same cloud native architecture and the same experience, whether it's private cloud or public cloud. Because at the end of the day, the goal is you should be able to write once and deploy anywhere. That's where we're headed towards, and that's where we're going towards.
That's a really interesting point. And I've heard that before. It's not a new concept, but it is a new possibility in this era. And I guess maybe let's go back to those AI agents. You made a really interesting point where some clients, 70%, 77% of their LLM calls are being generated by AI agents. I think these agents probably represent the most single disruptive force that we're looking at right now because of their capability to just go out and do things, to reconcile based upon dynamic data feeds in complex environments and execute and do certain actions. My big question, of course, is governance, audit trails, management. How do you orchestrate these things? I think there's going to be a lot of effort on all that. But in a way, I think it also further enables hybrid cloud architecture, which is going to be the future. What do you think?
100% agree. And look, when we talk about agents, right now we're just talking about software agents, right? But there is a world which is coming whereby we might be talking about humanoid agents. In fact, NVIDIA has this entire team out of Santa Clara called as Gear Laboratories, whereby they're already talking about that. But the most important thing is to understand what is an AI agent. So, in my humble opinion, an agent is something that has one or multiple of these four capabilities. They should have some capability in terms of long form instruction following. They should be able to do that. Second, they should be able to understand the APIs, so the tools there might be. They should have some level of self-reflection capabilities. And obviously, they should have some level of memory there is. Because the idea is if you're looking at a simple use case whereby you are trying to copy the humanoid software agent capabilities, that is where the world is today. You have to have all of these things today. But when you get to um, single shot learning or multi-shot learning, when you come to use cases like gaming, for example, that's where the embodied agents comes into the picture. That's the humanoid agent that I'm talking about. And you need to get to a point whereby you are getting to a point wherein a large amount of your erstwhile humanly automated tasks are being codified into a structure whereby the agents are smart enough to do that with a very high level of accuracy. So it is much more than what some people would call as RPA. And I do agree that agents are the next wave of disruption and the next wave of digital applications. And the example that I gave, the vision language models, that's a bank who are doing it today. And that's only the starting point. But the key point in that, and even I believe that keynote of mine is available online. But the key part of that is you have to be able to embed the processes to get to a high level of AI scaling because you can start with whichever use case might be. Text summarization and chat Q&A seem to be the low-hanging fruit. Like for example, they're making 30 million decisions a day, and before it used to take 2 hours to read a report for an analyst in the morning in a bank. Now it takes 2 minutes with a
Right.
significantly high level of output. So it's an
Right.
easy use case to get through with it, right?
Right.
But when you want to scale it across different lines of businesses and hundreds and thousands of practitioners, embedding that into your day-to-day processes is super important. AI can't be treated separately. It's not like your digital twin. It is part of your overall workflow. It is part of your normal architectural diagram. It is part of your normal processes that you have. And I think that's where agents come in super handy because they're able to deliver specific tasks for very specific use cases, and you get very high outputs.
Yeah, that's very interesting stuff. I think you're right about that. And I think Cloudera is certainly positioned with 25 exabytes of data under management. That's a pretty significant asset to have on the balance sheet and on the virtual balance sheet as well. Well, folks, look this gentleman up online. Abhas Ricky, ABHAS, Chief Strategy Officer for Cloudera. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, we're talking all things data strategy today, and I'm very excited to have Somesh Saxena online with us today. He is the founder of a company called Pantomath, and he also came from very serious data role over at GE, where he led a team, I think, of over 100 people and did all kinds of interesting things, enabling self-service analytics. So he knows a lot about data warehousing, information systems, and what Pantomath has done that I find very compelling as they are apparently the first company to have a true end-to-end observability platform for data, for the data plane, for understanding where the data comes from, where it goes, how it gets there, what the transformations are. Basically, it's that strategic view of data that we've talked about on DM radio from years and years and years ago. I used to ask folks from Informatica and Fivetran and other places like that, like, do you have a strategic view of all these ETL scripts so you know where there's redundancy, where maybe you have gaps, where there are some problems, and they would just kind of scratch their heads and look at me and go, not really. But tell us a bit about what you're working on, Samesh, and how Pantomath does its thing.
Sure. Thanks for having me on, first of all. And yeah, So Somesh Saxena, I'm the CEO and founder of Pantomath, as you said. Prior to Pantomath, quick background, I was, as you mentioned, the head of data and analytics for GE Aerospace. So for General Electric, I led a 100+ person team there supporting 18,000 data consumers for the company. Owned pretty much the end-to-end of the data ecosystem there. That was quite a few different programs. We had data analytics and BI, which included platforms, architecture, operations, data governance, big data analytics geared towards data scientists, robotic process automation, self-service data to democratize data, and so on. So quite a bit rolled up under me. During my time at GE, I saw my technical teams, my business stakeholders, executives all struggle with data quality and data reliability challenges. That's where the idea of Pantomath really came about. So Pantomath, in a nutshell, is a data pipeline observability and traceability platform, essentially a real-time monitoring solution for the end-to-end health of data pipelines, your inter-system or cross-platform data pipelines that go from data producers to data consumers to power data products and data reports. We monitor those pipelines in real time, as well as the health of the data itself flowing through those pipelines, right?
Yeah.
So really the vision is to automate data operations and drive data reliability, drive trust in data, eliminate poor decision-making with bad data. Really think of us as Datadog for data pipelines to really make sure that it is healthy and reliable at all times.
Yeah, that's really good stuff. And I'm a big fan of cliches. And one of the old ones I've always loved is a stitch in time saves nine, which basically just means, look, if you solve the problem right when you find it, you're going to save yourself a lot of trouble down the road. Because if you don't, then you're going to have a much bigger problem to address. And that's really what you're doing, is focusing on finding the problems as they occur and being able to remediate them, sometimes automatically. And if I understand it correctly, the foundation of this environment is a graph. So you build out a graph, you auto capture what's happening in a data environment to get the de facto end-to-end sort of horizontal view of the pipeline, or the pipelines, all of them. And then you've got this graph underneath, which is capturing information about which data goes where, what should it look like, what are the characteristics of this data, so the edges, if you will. It's got the nodes of the data sources, the edges, which are all the characteristics, and you're able to therefore get a baseline understanding of what it should look like. And that allows you to then know when something is out of order, right? When something deviates, which you can then go fix, right?
That is exactly what we do, right? And that's important because it's important to understand the problem first. You think of the data ecosystem, the modern data stack, it's built up with these disparate, disconnected even to some extent, unfortunately, tools and technologies that are really good at what they all do individually, but they all end up becoming a vertical in a horizontal view, right? The data pipeline by design goes from data producers to data consumers, Eric,
Right.
each of these hops in between. And there is no horizontal representation of this pipeline. You know, the data pipelines go from source systems to data integration tools, data lakes, warehouses, orchestration, ML ops, BI, but there is no horizontal view of the pipeline. So everyone trying to view that pipeline, even through an operational lens, is bound to view the problem and the pipeline from each technology's vertical lens of the world, instead of understanding how the different pieces of that
Right.
pipeline fit together. That's
Right.
what leads to, you know, a business user, an executive telling the data teams and IT teams, hey, we have a problem. You know, and even they don't realize sometimes they're making a poor decision with bad data, unfortunately. Only when they compare with a spreadsheet in their email, or worse off, they get called out in a meeting, someone questions, double check that number, something looks wrong, you know, and that's when they go to the IT or data teams. You know, it leads to wild goose chase, leads to back and forth troubleshooting, relying on tribal knowledge to manually reverse engineer this data pipeline to identify the root cause, understand the impact across the board. All of it causes productivity loss, not just for IT, for the business too. More importantly, data downtime, data reliability issues, lack of trust in data as an organization, with poor decision making on bad data. That's a problem I lived with on a day-to-day basis, and that's where everything you described there on the graph model really came to light, right? So what Pantomath does is we auto-discover every single data pipeline end-to-end. That's the first half of what we do. There's two foundational pillars in Pantomath. The first is auto-discovering every data pipeline. That is the traceability piece. So we snap into a data stack through a connector-based model. We have connectors for each one of these vertical technologies, you know, data integration, data lakes and warehouses, orchestration, ML ops, BI, and so on. And we snap in and auto-discover end-to-end data pipelines. Now, that's not just data lineage, which is a pretty well-known concept out there. You know, every data catalog has it. Some data observability players also have it. That is data lineage, which is the flow of your data. Table 1 and 2 are joined to create table 3. That's transformed to create table 4. Well, how did that happen? How did the data get there? Which
Right.
jobs are then transforming it? There has to be something moving your data, right? It
Right.
could be a data ingestion job, could be a transformation, BI job that moves, stitches, cleanses, transforms data. That's what they don't know. And so what we've done is taken this data lineage concept, married it with a pretty unique concept called job lineage. That's deep application level technical lineage that does true end-to-end pipeline lineage. That's cross-platform or inter-system pipeline traceability. Every
Right.
interdependency and relationship mapping is fully auto-discovered. We grab that metadata from each one of those connectors through APIs, through metadata repositories, normalize that in our data model, and then you have this plug-and-play framework that is tool and cloud agnostic and builds out this graph through our graph model. And
Man, that's cool.
that is a unique key differentiator because no one out there in the world does that, right? We're fortunate to have first movers advantage there where we can actually snap in the most complex Fortune 500 environments. You build for what you know. I built for the GE type of world because that's where I came from. And that's why we have pretty large Fortune 500 customers that are live with us that are seeing tremendous value because we snap in, we auto discover every
Yes.
one.
See, that is such an important part. And, I remember when the data catalog vendors came out, I can't remember if it was Alation or one of the other early players. And when I heard about this auto capture capacity where they would scan the information environment, pull back the metadata as you suggest of column names, and then sort of align things for you, I was like, wow, we're finally going to get somewhere. Because if you don't know what's out there, you can't govern it, right? You can't govern the unknown. You have to know something about a subject matter or a movement of information to be able to govern that information. And without governance, all bets are off. It's the wild, wild west.
Mhm.
And what I think is so interesting here is how you've got this graph that you dynamically build, in a fairly short period of time, it seems to me, that's actually pulling from all the different systems that are moving data. So the ETL systems, data virtualization, whatever is stepping into the picture to do something, all the transformations, for example. My good buddy Rick
Exactly.
Sherman used to joke, there's more than one T in that ELT, right? It's usually ELTTTT or something
Yep.
like that. And being able to know what that is and report on it, that's just, it's like shining a flashlight on your whole information environment, right?
Exactly. You're spot on. It's many T's, it's many different hops to get to the end result. And that's exactly why you need that end-to-end traceability because it's very complex. It's honestly a spaghetti mess, right? Um,
Right.
we have customers with thousands and thousands of jobs and tables or data sets that power one data report. And sure, those jobs and data sets don't just have one purpose, they may be populating quite a few things. That also makes it complex. That's a one-to-many correlation. And so now you realize it's not one thing that's broken. The one thing that broke caused 20 things downstream to be impacted. That's 20
Right.
now tickets, 20 reverse engineerings, and so on.
Right.
And that's why that horizontal view is very important. That's only one half of what we do, though, right? Because alone a horizontal view or alone monitoring won't solve the problem. It's the marriage of both. And so once we auto discover the data pipelines, Eric, we then apply monitoring to all of that, right? That's data at rest and data in motion monitoring. A data pipeline is built up of data at rest and data in motion components. Data at rest is a table in, let's say, a Snowflake or Databricks, or multiple of them, of course. And data in motion is all of those jobs, those data movements and functions that go about moving, stitching, cleansing, transforming data, as I said. So we monitor each one of those granular assets. We're monitoring the data at rest for making sure the data is fully complete. It's not missing row counts. It's not off. So the data volume has to be healthy. The data freshness has to be there as well. The data can be stale. It has to be refreshed at a certain time. And same for the data in motion components, right? The data has to actually move at the right time. The jobs can't fail. They have to start at the
Oh,
right
that's
time.
great.
All of these granular, nuanced things that the naked eye doesn't really catch. And at the scale and volume of a large enterprise, you can't build manual reactive checks for these things. We have to monitor these things in a fully automated way through metadata. And that's what we're doing. So we're
That's
monitoring.
Yeah,
Yeah.
that's amazing. Let's pick that up after the break. This is very, very cool stuff. We're talking to Somesh Saxena from Pantomath. We'll be right back. You're listening to Inside Analysis. Okay, folks, time for the podcast bonus segment here on Inside Analysis with Somesh Saxena from Pantomath. And we're talking about data pipeline observability. And Somesh, I love that you're taking these concepts from the traditional infrastructure observability world, like Datadog, Dynatrace, New Relic, all these folks. Because what do? They work with traces, metrics, and logs, right? That's what they're monitoring. And it's incredibly complex. But the beautiful thing is now in the age of AI and machine learning, well, guess what? Some of these systems can monitor very complex environments and know without exception, what happened, what went wrong, what went right, that kind of thing. And you're applying that capability on top of data pipelines so that you'll know what goes wrong, so that someone gets an alert that says, hey, and the impact analysis is huge. Hey, this system didn't load properly, which means these 9 reports that are going to the board of directors later today are going to be off. So go fix it, right? So you have early, like, leading indicators of data problems, right?
Yeah, that's exactly what we do. And I love the parallel with the application performance monitoring and infrastructure monitoring world. There's amazing technologies like Datadog, Splunk, Dynatrace, AppDynamics, New Relic, and so many others that have actually solved that problem extremely well. The process back in the day without these technologies was called splunking, where you have to go through the infrastructure logs to figure out what's broken without log indexing and so on, right? And that's where the name Splunk kind of came about, from what I understand. And you're spot on. We're essentially applying those learnings into the data observability world, into the data analytics ecosystem. And so what we're doing is monitoring the end-to-end pipeline after we auto-discover it. So the one half of Pantomath we talked about was snapping into a complex data environment and auto-discovering that end-to-end pipeline, showing the telemetry, the graphs, the end-to-end of how your data is flowing from data producers to consumers. And once we understand that, once we see the end-to-end horizontal pipeline, which, by the way, does not exist today without Pantomath, right? There
Right.
is horizontal representation of that pipeline. You have to view the problem from each siloed off vertical technologies lens of the world. Once we understand the end-to-end through Pantomath, we then monitor the end-to-end, but we're monitoring it with the context of the pipeline. So we're really monitoring every granular asset within that inter-system data pipeline, those jobs and data sets that sequentially make up an end-to-end view. We're monitoring each one of those things, those data at rest and data in motion components, Eric, with the context of the end-to-end pipeline. So now you understand what's broken, where it's broken, why it's broken, meaning root cause, and all the impact points around it you have to remediate to bring those pipelines up and running in real time.
You know what I think is so interesting here is I think that what you've built here is a great engine for optimizing the efficiency of data operations, which historically have been, I think, outrageously inefficient. And what I mean by that is, when I remember, like, way back at the beginning of DM radio in 2008, I would ask these questions, trying to wrap my head around all the ETL that's been happening here. And of course, what happens is you get the data warehouses that came around. It going back to the 80s and 90s, quite frankly, with Teradata and some of the other players. And when people figured out, oh, this is cool, I like this, well, then you had all these business people wanting their data into the warehouse. And so all these different batch windows are stacking up, and then you just got batch windows out the yin yang, and there's just data moving everywhere. And I would think to myself, this cannot be a very efficient environment. You've got to be moving the same data multiple times on multiple occasions, sometimes overwriting good data with bad, for example. You just don't really know because you didn't have that strategic observability. And then I also think about how much data we move that we probably didn't even have to move in the first place, right? Because what's the old joke that 80% or more of the data warehouse never even gets used, the data never gets touched. So it's like, well, what percentage is being used, and can we optimize the throughput of that data because that's what's being used? And I think that you have the enabling technology to open the door to making these environments incredibly more efficient. And especially up in the cloud now, that's going to save a ton of time, energy, errors, all kinds of things, because you can finally see and understand that end-to-end process, which means you can optimize the compute, the movement, the leveraging of data, all that fun stuff. Is that about right?
That is spot on too. That is exactly right. Today, something breaks somewhere upstream. Let's say, for example, the data ingestion layer, you're letting everything else run. And
Right. Right.
or even if it's not failed, even if it's
That's
running,
right.
it's green, it's successful, it's running
Right.
with bad or stale data, and you have to rerun everything again from scratch.
Right.
And that is causing a lot of compute spend. So we give users the ability to have circuit breakers to pause things right after there's an issue. So you're not wasting that compute, and then rerun things in an efficient manner. But you're right also, where without that end-to-end view, it causes problems beyond data operations. It causes data governance problems. It
Yeah.
causes issues on so many different fronts across multiple use cases that go beyond data operations and having healthy and reliable data. And that's why I think that end-to-end view is very critical, right? The first use case The first product line, if you will, in Pantomath is the observability and traceability use case around data operations.
Mhm.
But there's quite a few others we're supporting with customers. Uh, Automating compliance audits, right? For a CISO to
Sure.
understand how the data is flowing across
Sure.
the ecosystem, what the sensitive data tags are, and how are they propagating across the board? What's PII? What's PCI? What's export control? All of that, there is no way to track today, again, given that spaghetti mess we talked about, right?
Right.
So
That's
with a tool like
crazy.
Pantomath, we can automate compliance audits. To your point, how much are you spending on compute that you don't need to spend because the pipeline's inefficient? Maybe the pipe
Right.
isn't getting used. Are you correlating utilization metrics from what data is getting ingested? If you're paying a data ingestion tool based on the records it's ingesting, and no one's using that data downstream today, again, you don't have the end-to-end view. You can't even do that correlation, right? So there's FinOps and cloud cost optimization use cases,
Right.
governance use cases. There's
Right.
compliance use cases. There's so much more we can unpack, and I do believe that those are things that we don't just solve to some extent today. We can solve a lot better down the road as Pantomath hopefully becomes a multi-product company, and that's why the name's Pantomath. It means the one that knows it all. That's what the name of the company is. Pantomath is that foundational technology of the end-to-end. I think supports way more than just data operations.
I have to agree 100%. And I think this is fantastic, quite frankly. I think, as I've suggested, you have provided an enabling technology to finally, and I do mean finally, optimize the efficiency of information systems, of information landscapes to understand what's out there, what's being used, what isn't being used, and when something is incorrect, stop that so you don't use a bunch of compute that didn't warrant use because it was wrong or something. I mean, it's just crazy. So, folks, look this gentleman up online, Somesh Saxena of Pantomath. I'm sure we'll see them again on another show sometime soon. You've been listening to Inside Analysis.